can see these better, a little bit better right now. Yesterday, we first started talking about stereoisomers, all right? And if you look at these guys, the first thing I try to get across to you is that they're mirror images of each other, right? If you look at those guys, if there was a mirror between them, isn't that what you would see? Now, I'm going to try to teach you today how to draw these. That's the hard part. It's one thing to see the models and be able to tell that they're mirror images, but it's another thing to be able to draw them, all right? Turn that light, both lights off actually for a second. So other examples of mirror, that's what I've been showing you, that like model here, but your hands are mirror images, right? If you were to hold one of those molecules in your hand, they would pretty much be like a mirror image of each other. You can't superimpose one hand onto the other. And of course, yesterday I gave you that article on thalidomide. That's thalidomide. And again, it's just a mirror image of each other. And the one of them was a very harmful compound. The other one not so much. But it would the tragedy been averted if they only gave them the one? No, because it would have been converted in the body into the other one anyway. Racemization, that's called. That's what the word was trying to. You probably didn't understand what it meant. All right, let's learn today how to actually draw these guys. It's going to take a while. Okay. All right. In your notes. Oh, you have your notes yet? Did I give them to you? No. Let me give them to you. Put that backlight only on. Oops, sorry. All right, all stereoisomers are going to require a chiral carbon. That is, a carbon with 4 different things attached. If you look at all the examples I just showed you, they had to have a carbon in there that had 4 different things on it. Otherwise, you could superimpose them. So the first thing I'm going to teach you how to do is to recognize what's a chiral carbon. And it's going to be, you see all the room for examples. It's pretty much a blank sheet I almost gave you there. I'm going to draw those examples on here, and I'm going to refer back to them. And it gets kind of messy, kind of complicated. All right? But I'll do what I can to keep it straight. Because that's all we want to start out with, just identifying whether you even have a chiral carbon. Do you have a carbon with 4 different things bound to them? All right? So, let's do a couple of examples. Hold on a second. Example 1. Draw this, as I do. What I want you to do is I'm going to draw it here, and then I'm going to redraw it over here. Okay? So leave yourself enough room sideways. And I'm also going to put 1, 2, 3 examples. So leave yourself enough room that way too. Okay? Okay, take a look at, draw that guy first. And remember, you want to have enough room to redraw him over there. Sometimes, and you saw in one of my worksheets I've already given you, I had them drawn more like that than I had them drawn like what we did on Beaker. Because a lot of times in textbooks or even on the internet, even online, they'll draw them because they're using a word processor. They're going to try to draw them as much as they can in a straight line, just using basic characters like C and H and subscripts. Not the way I would draw them, which is just as stick figures and stuff, because it's harder to do that. And so a lot of times people just draw them out like that. So you need to be able to interpret that. What would this be if I were to redraw it our way? If I were to redraw it our way, what would this guy be? He would look kind of like this. You see why he would be that? And you can redraw. See why he would be the same thing as that? All right. And by the way, I mean, that's just my own method. In reality, of course, all these things, these are all just representations of them. Let's face it, I could have, even on Beaker, drawn this guy like this. Don't do this. Don't do this one. Right? I mean, that would be that guy on Beaker. I would just draw a line, and that's, by the way, if you look on, again, if you just type in image search for whatever, 2-methyl propane or whatever, you'll find some of them are drawn that basically. All right, just to save time. All right, now, here's my question to you. That has nothing to do. I just wanted to clear that up. here's my question. Do I have a chiral carbon in here? Do I have a carbon that's bound to 4 different things here? Now let's label them to make sure we know which carbons are which. We'll call this guy A, B, C, and D. A, B, C, and D. Which carbon is chiral, Harrison?
C.
Everybody agree it's C? Everybody agree? I'll put a little star by him because we're going to come back to him in a little while and I'm going to do something to him. All right? Okay? All I'm doing in this case, and by the way, if I don't screw it up, is I'm going to save this, go on with the notes, come back to it, and if it all works, do something else to this in a minute. Right now, I just want to find out if we have a chiral carbon or not. All right, so try drawing this guy. Look at this one. Oops, I want to use black because I got to use the colors later. Yep. This is example 2. All right, I squeezed an H in there. C, H3, CH, CH2, CH3. Okay. Again, if I were to redraw him in a second, well, I'll label them first. A, B, C, D, and E. Who do you think's the chiral carbon this time? B? No.
No, it's not.
It's none of them. There are no chiral carbons. Let me redraw them and I'll show you when I redraw them. It is kind of tricky sometimes. You got to be careful. You know I'm going to try to trick you.
Wait.
Okay? When I redraw him, you have to remember something. I have to have 4 different things around. 4 different things. And I don't. If I look at this guy, I've got, this is the one we thought was chiral, right? This guy here has an ethyl group around him. He has an H, but then he has a methyl and another methyl. If they're the same group, it doesn't matter if it's an H or not. If they're the same group, they're not going to be chiral. They're not going to be a mirror image of each other. They will be superimposable. Yeah.
So the first one is chiral carbon because it has a chlorine.
Right. As a chlorine, a methyl, an ethyl, and an H. So 4 different things. Exactly. That's what I wanted to make sure you point out to you. All right. Now, let's get the third one now. Last example here. You're going to find something interesting about this guy, too. Draw him, and we'll redraw him too, in the third example space. That's an F, by the way. All right? And let's label the carbons here again, to A, B, C, and D. What do you think? Do we have a chiral carbon this time? Who? Who's chiral this time? A, B, C, D, E? B? Okay, put a big star by him. But is that all?
No.
No. Who else? Yeah, D. So basically, both of these guys, this one here and this one here, are both chiral because they have 4 different things bound around it. So it is possible to have more than one chiral center in a carbon compound. And by the way, that will happen. We have a special name for those kind that have more than one. They're called diastereomers. We're going to talk about those. Not today, tomorrow. Won't get to them until tomorrow. You have a double. All right, so there's your first step. Look, this is going to be a long process. It's going to take us all today and all the double periods tomorrow just to give you the information on it. Then when we get back from Christmas, yeah, I wish. Then when we get back from the break, we will spend at least a couple of periods practicing them both on worksheets and in a lab with the models, and in a lab you'll have Kate Upton coming in again. And
get some new models.
I know. Well, give me another model. Who's the other one?
Tyra Banks.
Tyra Banks will be coming in. Okay. All right. I don't know. I thought she was like a host on some show, isn't she?
She is still a model.
Okay. All right. She's a model. So we'll have a model lab. We'll have worksheets. We'll use Beaker again. Yes, Beaker will do these. Yay. And there was much rejoicing. All right. But I'm going to come back to this. We're only in the first step. The first step is identifying a chiral carbon. Now, the next step is going to be, how do I tell them apart? Like, how do I tell if this guy's one of the mirror images or the other? How do I give a name to the two different mirror images? That's the big question this time. And to answer that, I got to go to a whole different thing. I got to tell you how to give priorities, how to assign priorities to all four of those things that are bound around him. I have to be able to tell them apart. And after that, I have to be able to draw them in 3 dimensions. And we're going to do all of that today, at least get the basics of it today. We're not going to get everything in. All right. Now, if I didn't erase that, which I don't think I did, let's go on to the next part of your notes here. Assigning priorities. So we're going to give a different name to everything that's bound around. Every one of those 4 different things has to have a different name. All right, so the green, we aren't going to have it. At the molecular level, you don't have green, orange, yellow, and black. You're going to actually have atoms. So carbon, we're going to use these as when I start drawing these. Carbon will be the black one, makes sense. The lightest color is usually hydrogen, usually white or yellow. What do you think green? What do you want to use for green?
Bromine.
No.
Chlorine.
Chlorine. I always think of green for chlorine, green gas, right? And we'll use the orange one will be, bromine or whatever else we need to throw in there. All right?
What makes a difference?
It doesn't, but assigning priorities. 2 rules. First of all, obviously we don't just have colors. We have real atoms there. So how will we assign the priorities? We'll basically assign them on how heavy they are, the things that are bound to them. The heavier things will get the higher priority. It's that simple. The heavier atoms get the top priority. And you just list them in order. Now sometimes when you do that, there'll be a tie.
Tiebreaker, right?
You got to have a tiebreaker. Exactly. Fight a death match. The tiebreaker goes to the guy who'll be bound to something else, and the next heaviest thing that he's bound to. So if 2 atoms connected to the same guy have the same atomic mass, the highest atomic mass of adjacent atoms will take the priority. So guess what? It's time to go back to those examples I just did and see if we can't assign priorities to everybody that's around each of those chiral carbons. That's what I'm going to do. So I'm going to put those back up here, and I want you, with me, to assign the priorities, going by heaviest to lightest atomic mass. All right, here we go. Actually, I have to kind of get a fresh board to do this. There. All right, there are those same examples we just did. Now, let's look at this first guy over here, and I'll do it on the ones that you can see better, and we'll use a different color here, red, to circle them. Of the 4 things that are bound around, who do we have bound around? We have a chlorine, a methyl group, an ethyl group, and an H. Who's the heaviest? Who's got the highest atomic mass of the things he's bound to? Chlorine, carbon, carbon, or H? Chlorine. Now, some of you might be saying, well, what if I added up all of these guys? No, you don't do that. You only go by the next atom he's bound to. So chlorine beats out carbon. He gets number 1. Okay? So chlorine, this chlorine atom is number 1. So put a little 1 by them, circle him. Told you it's going to get messy. Here's where it gets messy. What's the next heaviest thing? Carbon, right? But there's a tie. This carbon and that carbon are basically the same. So I have to go to the next guy. This carbon's bound to an H and H and H. This carbon's bound to an H and H and a carbon. Carbon's heavier than H. So he'll win. He gets second priority. Got it? Who gets third priority? The other carbon, exactly. This guy up here gets third, and this guy down here, the H, it's implied H, we all know that, is going to be the fourth priority. There you have it. Nice. Now watch what happens. This will actually happen to you if you ever make a mistake like this. Say, oh, I don't do this, please, but I thought he was a chiral carbon. So I'm going to try to assign priorities. I will give him number 1, and then I go to try to get this guy. What happens? They're exactly the same. There's no tiebreaker, so I can't do it. I can't have priorities. All right, so that's why I know that guy does not have a chiral carbon. All right, let's get out of this guy. This is where it gets really ugly. I'll use red for one side and blue for the other. Doing this one here. Who's the heaviest of these guys bound to that carbon? Chlorine. Still chlorine. He's number 1 again. Who's number 2?
Fluorine.
Fluorine, exactly. Number 3? Well, there's a carbon here and a carbon here, but which guy's going to win? Yeah, the one on the right. This big guy over here is going to win because he's also bound to another carbon. And this guy over here, the methyl, will be the lowest priority. See, most of the time, not most of the time, sorry, I shouldn't say that. So that's a poor way of saying it. Hydrogen, if he's in your chiral carbon, what will he have to be? He has to be last. Why? He's the smallest, he's the lightest atom. Okay? But does that mean hydrogen is always last? No, because you don't always have a hydrogen. So you don't have a hydrogen in this guy, he's not bound to hydrogen. The lowest priority bond does not have to be hydrogen, but if hydrogen's in there, it has to be him who's the lowest. He has to be the lowest one. All right, let me do the other one to keep from getting too ugly on this side. Let's do the other one over on this one. How would I do the chiral carbon on this guy? I'll use blue this time. Who's highest?
Bromine.
Bromine's 1. Okay, who's 2?
The left side.
This whole guy over here would be 2. 3? Yeah, because he's next heaviest. Carbon-carbon tie, but he wins. He's 3rd. And then this hydrogen, which is implied here, is 4th. There you have it. So you've now done, you've pretty much gotten through the first 2 steps, pretty much, of doing these. You have to, first of all, pick out, do we have a chiral carbon? And then, once I know there's a chiral carbon, can I assign the priorities? But that still won't help me tell which one of the configurations it's in, because I've got to see them in 3D. I've got to see these guys in 3 dimensions. Okay? Written flat like that, can't do it. And this is where it's going to take, this is probably the hardest step, where you're going to have to be able to see the molecule in a three-dimensional molecule in a 2-dimensional representation. I'm going to show you how to draw them, but mainly I'm going to be drawing them for you, and you have to just interpret them. All right? So everybody good with that so far? Yeah. All right. I'm going to stop here for a second.